So here's an equation which seems to be homogeneous. So let's first see if the equation is in fact homogeneous. M of x comma y is x. So if I replace x by cx and y by cy, I end up getting simply cx, which is c times x, but x is in fact m. So it is homogeneous because the degree here is 1. In other words, that's 1. We'll do the same for n. Replace x by cx and y by cy. We have cy minus 2 times cx. If I pull c out, I'll have y minus 2x. But y minus 2x is simply n. So we'd have c times n x comma y. The degree is 1, so homogeneous. So both m and n are homogeneous. Therefore, this is a homogeneous equation. So what I'm going to do is I'm going to divide by x on both sides. So I have dx plus y minus 2x over x dy equals 0, which would mean dx plus y over x minus 2x over x times dy equals 0, dx plus y over x minus 2 dy equals 0. And now I'm going to use the substitution. Keep in mind, I could either use x over y or y over x, and in this particular problem, y over x just popped out, so I'm just going to use u equals y over x, which would imply y equals u times x. I'm going to take the derivative of y with respect to x on both sides. So on the left-hand side, it'll be dy over dx. On the right-hand side, we have to use product rule, u times the derivative of x, which is 1, plus x times the derivative of u with respect to x. So I'm going to rewrite that equation by dividing dx on both sides. So 1 plus y over x minus 2 times dy over dx is equal to 0. 1 plus u, because that is our substitution, minus 2. dy over dx is u plus x times du over dx equals 0. 1 plus u times u minus 2 plus x times u minus 2 du over dx would equal 0, which would imply x times u minus 2 du over dx was equal to minus 1 minus u times u minus 2. Now, I have x times u minus 2 du over dx. Multiply by dx on both sides. I'd have minus 1 minus u minus 2 multiplied by dx. If I pull a minus out, which is in common, I would simply have 1 plus u times u minus 2 multiplied by dx. I'm going to FOIL to get 1 plus u squared minus 2u dx. And that would equal to x times u minus 2 du. That looks like a separable equation. If I move all the u's to one side and the x's to the other, I have u minus 2 du. That simply is u minus 1 squared. So when I move it to the denominator over here, I can replace it by u minus 1 squared. And I have dx over x on the other side. So that would reduce to u minus 1 squared. Now this is a separable equation and we can integrate on both sides. So integral u minus 2 divided by u minus 1 squared du equals integral du over x. Now we can use long division, we could use partial fractions, one of those techniques to find the integral on the left hand side, but the easier approach to split the numerator up as u minus 1 divided by u minus 1 squared times du, which, since we have a common denominator, I could write it as u minus 1 divided by u minus 1 squared minus 1 divided by u minus 1 squared du equals ln of x plus c. The first term, the u minus 1s would get cancelled. I'd simply have 1 over u minus 1 times du. The second term would be 1 over u minus 1 squared times du. And that would equal to ln of absolute value of x plus c. If I use a substitution, let's say t equals u minus 1, then dt would be du. So the first integral would reduce to dt over t. Second would reduce to dt over t squared. And that would equal to ln of x plus c. Integral of dt over t is ln of t. The second integral would reduce to negative 1 over t. Replace ln of t by u minus 1, or t by u minus 1. So we have ln of u minus 1 plus 1 over u minus 1 equals ln of x plus c. We can't stop there. We have to go forward and replace u by y over x. So we will have ln of y minus x over x plus x over y minus x equals ln of x plus c. I just simplified now I'm going to rewrite, using the properties of logarithm, the first expression as ln of y minus x minus ln of x plus x over y minus x equals ln of x plus c. I missed a negative sign here. Apologies. Minus. That minus is right over there. So minus. So the ln on the left hand side and the right hand side will get cancelled. And we will have ln of y minus x plus x over y minus x equals c. And that would be our solution. So the next problem, we have m of x comma y as x minus y and n of x comma y as x plus y. I'm going to replace x by c times x and y by c times y. I get cx minus cy. C comes out, so I have c times x minus y. But that x minus y is simply m. So I have c times m x comma y. So m is homogeneous. Likewise, n of cx comma cy equals cx plus cy. If I pull the c out, I have c times x plus y. I get c times n x comma y. So both of them, both m and n, are homogeneous. So we have a homogeneous differential equation. So it really doesn't matter which substitution we use. You could either use x or you could use, you could either use y over x or you could use x over y. So I'm going to divide the entire equation by x. So I have x minus y over x dx plus x plus y over x dx dy equals 0. I have a common denominator, so I split it up. If I split it up, I'd get 1 minus y over x dx plus 1 plus y over x dy equals 0. I'm going to use the substitution y over x equals u, because y over x just popped up based on what I did. So y would equal u times x. Take the derivative with respect to x, so dy over dx would equal to u times the derivative of x, which is 1, plus x times du over dx. and that is product rule. I'm going to make the substitutions now, so 1 minus u dx plus 1 plus u, replace dy over dx. Forgot to divide, so let me divide by dx on both sides. And dy over dx is simply u plus x times du over dx equals 0. So 1 minus u plus 1 plus u times u plus x du over dx would equal 0. Distribute, we will have 1 minus u plus u times 1 plus u plus x times 1 plus u du over dx equals 0. 1 minus u plus u squared plus x times 1 plus u du over dx would equal 0. The u's would get cancelled, so I will have u squared plus 1 plus x times 1 plus u du over dx is equal to 0. I'm going to move the second term to the right hand side, so minus x times 1 plus u du over dx. That is a separable equation, so if I rearrange the terms, I would have dx over x with a negative equal to 1 plus u over u squared plus 1 times du. Now all we have to do is integrate on both sides. So integral of minus dx over x equals integral 1 plus u over u squared plus 1 du. So negative ln of x equals integral du over u squared plus 1 plus u du divided by u squared plus 1. The first integral is easy. That is simply tangent inverse of u. The second integral requires a substitution. I could use the substitution t equals u squared plus 1, which would imply dt is 2u du, which would imply u du is dt over 2. So the integral would reduce to dt over 2u. Oh, sorry, t. So we have negative ln of x equals tangent inverse of u plus 1 over 2 ln of t. But t is simply u squared plus 1, so we have minus ln of x equals tangent inverse of u plus 1 over 2 ln of u squared plus 1. I'll put the constant in there. So minus ln of x, replace the u, which is y over x, plus 1/2 y squared over x squared, plus 1 plus c. And if I'm trying to simplify here, so negative ln of x would equal tangent inverse of y over x plus 1/2 ln of y squared plus x squared over x squared plus c. Using power rule of logarithms, this would become minus ln of x equals tangent inverse of y over x plus ln of square root of y squared plus x squared over x squared. Plus c. Which would then become equals tangent inverse y over x plus ln of square root of y squared plus x squared divided by square root of x squared is simply x plus c. Again, using the properties of logarithm, I'd have negative ln of x equals tangent inverse of y over x plus ln of square root of y squared plus x squared minus ln of x plus c. So those two would get cancelled. I'll move the c to the other side. It'll become negative c. But negative c is yet another constant, so I'll just call it as c1 equals tangent inverse of y over x plus ln of square root of y squared plus x squared. And that should be the final solution. You can simplify it further, but I think we have done sufficient simplification at this point, so this is good enough. Here we have an initial value problem, and m of x comma y is x plus y e raise y over x. I'm going to replace x by cx and y by cy to see if it's homogeneous. I have cx plus cy e raise cy over cx. The c's would get cancelled. We have a common c. I have x plus y e raise y over x. So that is just m. So we have m of x comma y to be equal to c times m of x comma y. So m is homogeneous. Likewise, n of x comma y is negative x e raised y over x. I'm going to replace x by cx and y by cy. Have negative cx e raised cy over cx. C's get cancelled. Have negative cx e raised y over x. But that term is the same as n over there. So we have c times n of x comma y. M of x comma y equals n of x comma y. So n is homogeneous. So both m and n are homogeneous. So we have a homogeneous DE. Since y over x is popping up, I'm just going to divide the equation by x on both sides. So x plus y e raised y over x dx over x minus x e raised y over x dy over x equals 0 over x, which is simply 0. Have a common denominator. So I have 1 plus y over x e raised y over x dx minus the x's would go away, e raised y over x dy would equal 0. I'm going to rewrite it at this step. 1 plus y over x e raised y over x dx would equal e raised y over x dy. 1 plus y over x e raised y over x would then equal e raised y over x dy over dx. Now, since we use the substitution, u equals y over x, y would equal to u times x, which would imply dy over dx is equal to u times the derivative of x with respect to x, that is 1, plus du over dx times x. So rewrite the equation in terms of u. 1 plus u e raised u equals e raised u times u plus du over dx times x. So we have 1 plus u e raised u equals u e raised u plus e raised u du over dx times x. These two terms would get cancelled and we'll have 1 equals e raised u du over dx times x. That looks like a separable equation. Move all the x's to one side and u's to the other. So dx over x would equal e raised u du. Integrate on both sides. Integral dx over x is equal to integral e raised u du. Integral dx over x is simply ln of x plus c. Integral of e raised u is simply e raised u. Now, since this is an initial value problem, y of 1 is 0, and we know that u is y over x. So since y of 1 equals 0, we have ln of x e raised 0 over 1. So ln of 1 is 0. So 0 plus c equals e raised 0, which is 1. So the value of the constant is 1. Therefore, the solution is ln of x plus 1 equals e raised y over